Okay, here's an analog signal. Again, it's an analog DC signal. Down here we have a low voltage. As the part moves, the voltage increases, then it comes back down again. The most common sensor for analog DC is a throttle position sensor. The throttle position sensor is the driver demand sensor that tells the computer where's the throttle located at. The plate. Is it closed, halfway open, wide open? Now, also besides a TPS signal, an analog DC voltage can be a M.A.P sensor, which is here. You can see it's a 3-wire sensor. Power, signal, ground. See, power, signal, ground. But instead of a throttle position, this sensor sends a voltage back to the PCM based off the pressure inside the intake manifold. Absolute manifold, absolute pressure sensor. This is the PCM load sensor. This is how the PCM knows there's a load on the engine. Meaning when the throttle opens up, my pressure increases, vacuum decreases. That tells the PCM the vehicle is under a load. The signal wire generates a high voltage back to the PCM, indicating the car needs more fuel to help compensate for the load. For example, let's say this was the signal from the M.A.P sensor. Here I'm at idle, and I step on it hard to go on the freeway. My voltage would go up. And to the PCM, that increase of voltage from the M.A.P sensor indicates the car is under a load. Give it more fuel. My mass airflow sensor is also a load sensor, but this has air running through it. The more air that runs through it, I'll probably explain it later on, but the more air runs through it, the more voltage it needs. The more voltage it generates, the more fuel it needs to compensate for the air. So my M.A.P sensor and my airflow sensor are both load sensors. They are the components that tell the computer the vehicle is under a load and needs more fuel. And a load is defined as more torque on the engine, requiring more fuel to do a certain job, like get on the freeway or passing somebody. That's a load sensor. Let's go to the next one.